Hi, I'm Marco Panizza. I'm the European Application Manager for Vicor, and today I'm going to explain you how to use our modular DC-DC converters to meet the European railway standards. Electronical and electrical equipment designed for use in railways must meet fundamentally two standards. One, the most common, is the IC 571, also called as EN 5155. Equipment used for deployment in the UK must also meet the so-called RIA 12, which is a standard designed by the Railways Industry Association. Rail applications are characterized by harsh environmental conditions. The mechanical environment can include high level of shock and vibration. Operating temperature is another key challenge, as products must work in Nordic winter conditions as well as in hot Mediterranean summers. Space is often limited, requiring small size and high power density. The limited space can also present cooling challenges, and products with heatsinks baseplate are ideal solutions. The voltage in many rail applications can vary over a wide range. EMC is another challenge for engineers in this industry. The power system must not only generate minimal EMI, but should also be immune to interference from noisy sources such as electrical motors. Finally, reliability is an important consideration. A failure in a train's electronic system can be very expensive and, in a worst case, could be extremely dangerous. Let's look at some of the specific requirements of the rail standards. This table shows the input voltage requirements of EN 5155 and illustrates how, in most cases, Vicor modules meet or exceed them. For example, a nominal 36-volt input is specified as ranging from 25 to 45 volt. Vicor's module exceed these, offering an input range of 21 to 56 volt. In some cases, it is not possible to meet the specification with a standard off-the-shelf DC-DC converters. At Vicor, we offer a custom service that allows to develop modules according to the customer specification, and this without NRE or minimum order quantity requirements. This is a service that has been used by many customers to develop their own railways applications. Resistance to transient and surges is a requirement of the specifications. The specified 1800 volt pulse for 50 microseconds delivers only 100 millijoule of energy. In this case, a standard transient suppression device is able to withstand this energy level. The RIA 12 standards requires also that the system be able to withstand a surge which is 3.5 times higher than the nominal input voltage for 20 milliseconds. In this case, as the input source resistance is only 0.2 ohms, the energy levels of this surge is very high, and a normal transient suppression device will not be able to withstand this. An active clamping circuit provides a perfect solution. Fast, high voltage spikes are clamped by D1, whilst the active part of the circuit formed by D2, D3, Q1 and Q2 will limit the surge. The diode and capacitor form a charge pump to keep Q1 in conduction during normal operation. When overvoltage occurs, D1 conducts, causing Q2 to turn on. This holds the gate voltage of Q1 to the clamping voltage of D3. The output voltage is therefore D3's clamping voltage minus Q1's gate source voltage. The DC-DC converter is therefore protected during the voltage surge. Once the surge is over, the circuit returns to normal operation. The standards provides detailed specification related to shock and vibrations and requires the equipment to withstand vibrations on all the three axes. Vicor modules are encapsulated in epoxy resins, and that makes them immune to mechanical stresses. However, engineers must pay attention to the PCB designs and wirings to avoid any relative movements of the parts and avoid failures during operation. Operating temperature is defined into 4 different classes according to the severity of the application. The lowest class, T1, defines a temperature from minus 25 to plus 55 degrees centigrade, whereas the most stringent one, class TX, defines the temperature range from minus 40 to plus 70 degrees C. EN 5155, however, also states that the cubicle can have an over temperature of 15 degrees for up to 10 minutes. So electronic systems must operate from minus 40 to plus 85 degrees if they are to meet the requirement of TX. Vicor's modules not only meet these requirements, but also provide for baseplate mounting, which is often used in rail application where the cabinet is used as a large heatsink. There is a lot more information at vicorpower.com. In addition to our product technical data, you can access our extensive technical library and get more information about railways applications. Or you can improve your technical knowledge on power supply designs by taking our video tutorials. Thank you for watching, and don't forget to check out our other videos.